Most conversations about the future of geothermal focus on the production of heat or electricity with the resource, touting its baseload capability as a way to reduce our future reliance on batteries to provide grid stability. However, there is an overlooked potential for the Earth itself to function as a massive grid-scale energy storage device through storage of excess energy in the subsurface. Currently, with increasing amounts of solar and wind energy being placed on the grid, there is a race to not only develop energy storage devices that can handle the scale of electricity needs at times when the sun is not shining and the wind is not blowing, but also to find secure and mine heavy metals like lithium, which will be required to build grid-scale energy storage systems. But what if instead of storing massive amounts of solar and wind energy in lithium batteries, we were able to store that energy underground, withdrawing it at a later time for use directly to heat homes or for industrial purposes or for electricity production? What are the advantages and disadvantages of this Earth as a heat battery approach? Let's explore.
Hello, everyone. Welcome to Pivot 2022. This is going to be an incredible week focused on geothermal energy. We'll be hearing from some of the leading startups around the world discussing some of the most pressing topics in geothermal and, of course, the pivot from hydrocarbons to heat. I'm Nick Cestari, a geologist with Oxy and host of the Core Knowledge podcast. And I am so excited about geothermal as an energy source and just all that it has to offer us in the society and this world moving forward into this energy transition and reaching net zero, low carbon goals, sustainability goals, and just overall helping this planet as a whole. And I'm just so honored to be moderating our first panel here this year, Earth as a heat battery. Could the subsurface solve energy storage? Solving for peak demand in a cost-effective, reliable, and low-carbon manner will be paramount in the coming decade. So can geothermal be more than just electricity and heat? Does it play a role in the future of electricity systems? Well, I'm here today to find out exactly the answer to those questions. So now I would like to introduce my panelists and welcome them to the stage and give a brief introduction to themselves and what they are currently working on in regards to Earth as a heat battery. So Jack Norbeck, if you could please go ahead and introduce yourself and give a brief introduction.
Can you hear me now?
Yes.
Great. So good morning. Thanks, Nick. My name is Jack Norbeck. I am the co-founder and chief technology officer of Fervo Energy. I run our exploration program, also our well field development and engineering design, as well as our technology innovation work. Very excited to be here at this event this week. Thank you.
Yeah, thank you. Well, Joe Batir, could you go ahead and introduce yourself and give a brief introduction?
Yes, thanks, Nick. Thank you, everybody, for joining us. My name is Joseph Batir. I'm the geothermal lead for Petrolern. Been doing geothermal research and been in the geothermal space since 2010, focusing on resource exploration in both volcanic and sedimentary settings, both high and low temperature settings. So excited to be here today talking about thermal energy batteries, what we call synthetic geothermal reservoirs. And for those of you who don't know Petrolern, we are a consulting and technology development company focused on utilizing legacy energy data and infrastructure to expedite renewable and low carbon energy development. So thanks, everybody.
Awesome. Thank you, Joe. And next we'll go to Palash Panja.
Hi, my name is Palash Panja. I am a research assistant professor in the Department of Chemical Engineering, University of Utah. I am also a research scientist at Energy and Geoscience Institute. You know that we have the biggest EGS project, Enhanced Geothermal System project at Energy and Geoscience Institute. So I am working with geothermal for last 5 years with Forge project, and recently I am working in an energy storage project, mainly the underground thermal energy storage. Thank you.
Thank you, Palash. And lastly, we'll welcome Travis McLing.
Hello, I'm Travis McLing. I am with the Idaho National Laboratory, one of the nation's energy research laboratories. I lead the geothermal research here at Idaho National Laboratory. I am a research geochemist, and most of my work has been associated with developing methodologies to find geothermal resources and to evaluate geothermal energy storage and the efficiencies that can be gained there. It's an area that has a great deal of potential, and it's an area that we here at the lab view as a rising star amongst the energy opportunities within the global energy perspective. Thank you.
Yeah, thank you all, and excited to talk with you guys today here. So I've outlined a series of questions, and some of them I'll direct to each of you, and then others I'll just kind of ask for discussion among the panel as it applies to all of the work that you're doing. But as some of you may have heard in the intros from our panelists, there's a lot of acronyms in the geothermal space, as there are in most energy spaces. And so you heard a few of those, but I want to start kind of by framing things in the idea of Earth as a heat battery. So we have a lot of acronyms out there: AGS, EGS, SGR, as Joe mentioned, geothermal battery, GB, IRES, RTES. So kind of want to expound on that a little bit and give some clarity here on what we're talking about today. So Joe, I'd love to go to you first and just kind of ask for you to expound a little bit on what you mentioned in your intro about Petrolern's work with regard to the synthetic geothermal reservoirs and what these are specifically, and how this is different than our EGS, AGS systems, and what this can do for moving forward in the geothermal industry in the future of this space.
Yeah, absolutely. So when it comes to SGR, or synthetic geothermal reservoir, what we are referring to is actually targeting a high enthalpy, high energy geothermal reservoir. That's what we're trying to develop and make, where what we're doing there is we're calling it synthetic because we are charging that with some type of renewable energy resource, either curtailed wind or curtailed solar, or set up specifically with a concentrating solar power dedicated system. And the whole goal there is to take geothermal truly everywhere, because now wherever you have wind or wherever you have solar power, but you don't have a geothermal resource, now you can set that up as long as you have the right reservoir. So we've got the reservoir and we are synthetically creating geothermal in it. And from there, I guess I'll stop there, because there's a lot more to talk about, and I don't want to take up too much time.
Yeah, no, thank you. No, I appreciate that. Gives us some frame for moving forward later. So now, Palash, I'd just like to get a little bit from you as well, since similar concept, but you have work that's being done on geothermal battery energy storage, and I just want to kind of get your perspective on that work, and also just one piece of point of some of the learnings of why there's been a lack for the commercialization of subsurface storage.
Yeah, I think the GB, or geothermal battery energy storage, is exactly the same as a synthetic geothermal reservoir. The essential component of the GB is like 3 layers. One is in the middle, the main formation or storage container, and 2 layers on the bottom and one on the top are the insulating layers. I think finding this setup is difficult right now. If we can find out like suitable middle reservoir with the suitable insulating layers on the top and bottom, we can create GB. And suitable means in the formation we need little higher permeability, like 100 millidarcy, then higher porosity to store that hot liquid, hot fluid, most probably hot water. Yeah, we can discuss more then later.
Yeah, thank you, Palash. And then I want to move to you, Jack, and kind of now that we have those 2 examples, kind of talk about what Fervo is doing and the kind of the other side of not using necessarily curtailed wind and solar, but the idea of the in-reservoir energy storage work that you guys are doing.
Yeah, absolutely. I'm so excited to be part of this panel on energy storage because it's a topic that's going to be really key to allowing geothermal to increase its capacity and add value to the grid. We all know that geothermal for the longest time has been thought of as a baseload energy source, but the times are changing, the markets are changing. When we go out and talk to customers, nobody wants baseload energy anymore. And so we're working on some technology that we call in-reservoir energy storage that allows us to curtail production when the price of power is low, or the value of energy is low, and then dispatch that energy at later times when it's more valuable at relatively high recovery factors. And so, yeah, I can get into more details on that, but at a high level, that's some of the work that we're doing.
Great. No, thank you, Jack. Thank you all for the kind of perspective. And I want this next piece, I'm going to start with you, Travis, on it, but I kind of want to take what we've now kind of learned, the acronyms, kind of have an idea of what we're talking about here today in particular. And I want to move to, how does geothermal, Jack alluded to this, how does geothermal play a role in the future of electricity systems and achieving, a net zero grid? Does this make geothermal more competitive in energy systems that today are heavily reliant on intermittent renewables? And how does geothermal help to make a more resilient grid? So I'll start with you, Travis, just on some thoughts on that question.
Yeah, and again, Nick, thank you for giving me the opportunity here today. I'm going to take a broader perspective on this whole story of, and again, the acronym salad that's out there is kind of confusing, but for the sake of this discussion, we'll just talk about an earth battery. Is here at our lab and the research that we're doing, we're pretty agnostic to the source of that, the energy that goes into the subsurface. Basically, from my perspective, is that any of the energy that we're wasting or currently bleeding to the atmosphere through cooling towers or other methodologies from fixed sources is energy that can be captured and stored in the subsurface and recovered and used, whether it's 50-degree centigrade heat coming off a building or off a data center, and that can be then used in for district heating applications, or whether it's high-grade, high enthalpy heat coming off of concentrated solar that can be used to stored in the Earth's subsurface and then recovered for use for power generation. The whole concept here from my office, my perspective, is that geothermal energy has to mean something to folks that live in Columbus, Ohio, in Boston, Massachusetts, not just Reno, Nevada. And this is the struggle that we've had for a long time, is that geothermal is defined strictly as a high enthalpy power generation system from very hot systems that were very noticeable at the Earth's surface. I wouldn't go into more detail as we go on, but essentially, if we're wasting energy or we're using methodologies to bleed that energy to the atmosphere, we should be recapturing that energy and storing it in the Earth's surface. It is very effective and very efficient methodology to help decarbonize and reduce our dependence on fossil fuels.
Yeah, no, absolutely. And would love to dive in a little bit here to each of you, that specific work that you're doing. So I kind of want to circle back, Joe, and give you a little bit more of a platform to kind of expand on SGR and kind of give us an idea of is this something that you're looking at in all of your projects for geothermal? Is this something that helps geothermal projects become more attractive? Is this something that is tailored to certain applications? Is it purely seasonal? Give us a little more of the details behind the SGR work that you're doing at Petrolern.
Yeah, so when it comes to SGR, it's not something that we look at with every single project. We do consulting on low temperature, high temperature, looking at volcanic settings, sedimentary settings, and sometimes you don't necessarily need that battery storage. You can utilize the energy as base load. And sometimes you don't need high grade, high temperature heat. So there would be no reason to generate or concentrate power to 200 degrees Celsius to then produce electricity. So it's not something we're always looking at, but in areas like Columbus, Ohio, as Travis pointed out earlier, or other areas that we've worked where people ask, can we use geothermal here? And I look at the map, and the temp or the heat flow is 50 milliwatts per meter squared. You're not really going to have a natural geothermal system there, but you may be in the middle of the best wind resource in the world, and in that scenario, that's not being developed because it's an intermittent resource, and there isn't the need or the demand for all of that power. But if you found a way to store that power and then put it on the grid when it's necessary, or use that energy as a heat supply and turn that intermittent renewable into a 24/7 baseload heat for industrial processes, then it becomes something that is more valuable. And so that's really what we've been looking at as we're thinking about the same idea of how do we actually get to net zero. One of those ways is to increase renewable energy penetration, which ultimately means some type of storage of power. And why would we not use the earth? The earth has done a great job of storing heat its entire life, so to speak. So why not utilize those same processes and those same thermal properties for further energy storage?
Yeah, no, absolutely. That's really great. I think it's the looking at these projects and just deciding on what is needed and how you can attack it is important, and kind of want to go a little into that of just some of the examples we've seen. Locations such as Berlin or other areas are using the aquifer thermal energy storage, or using this idea of the seasonal, for buildings, or kind of, as Travis alluded, just for all different types of uses. And I think that's one key thing. We're talking about energy storage today, which is just one more reason geothermal is not just a one trick pony. It's not just electricity. It's not just heat. So I think you want to go to, I'll start with Palash and then go to the rest of you if you have any thoughts on this question. But, how do we really pitch this and incorporate this into geothermal and make this part of what people think about when they think about geothermal? And does this have applications in all aspects of, heating buildings and heating and cooling? Do we pitch it to them as well as the agricultural business? How do we get to this place where it's not so parceled out and kind of thought of as very separate projects, but in the end of the day, it's all geothermal?
I think we should consider this as energy storage project than geothermal. It's better because it can be used for direct heating also. For direct heating, problem is that we have the geographical constraint. We need that GB or the underground storage near the building where we need the heat for direct heating. But for other purpose like electricity generation, we don't need that. We don't have the geographical constraint, because whenever we have the excess electricity from wind or solar, it can be transported through grid, and wherever we have that geothermal synthetic geothermal reservoir, we can heat up water or other fluids and store it. So that's one advantage of the GB, that it is not location constrained. So I think that will help to commercialize the GB.
Yeah, no, that's great. And, I think that's kind of what I was getting at, is just this idea that it's not location, dependent. And I think it's a really important piece, and I want to, while we're moving along, and obviously time will move. So I want to make sure we touch on some of these important aspects. And so obviously geothermal as a base load is a topic that's been the topic. It's high capacity factor, it's resilient. There's a lot of benefits to this. So I want to talk about some of this in regards to the idea of geothermal battery or the in-reservoir energy storage. So Jack, I'll start with you and kind of go back to Fervo's approach. And you kind of, mentioned it briefly, but want to hear a little more detail on, the efficiency and actually what are the numbers behind this in-reservoir energy storage in terms of the turnaround and actually what you're recovering from this model?
Yeah, for sure. And so this is something we've been working on at Fervo since 2017, 2018. And, it was really sparked. I remember walking into a meeting actually with the California Energy Commission at the time. And the first thing they said is, we love geothermal, but baseload energy is dead. And so that was really a wake up call for us and thinking about, of course, they had things like the duck curve on their mind. And that challenge that the duck curve represents in California has only gotten worse. And California is only the tip of the spear there. It's going to get more challenging in other markets, especially in the Western US, where we have great geothermal resources. And so, we have to think about solutions to improve the flexibility and the dispatchability of geothermal power. Now, when I think about what is a battery, fundamentally, it's something that can take load off of a grid and then dispatch it at a later time when it's more valuable. A lot of people are focused on, okay, well, let me, how can we actually absorb excess wind or excess solar? I think there's a lot of exciting work to be done on that, and it's for sure a problem. I think about it a little bit differently. If you think about it from the utilities perspective or the grid's perspective, if you're expecting a load, let's say baseload geothermal of 50 megawatts to be delivered to the grid, if you're able to curtail that load, actually from their perspective, it looks a lot like a battery that's absorbing that energy. And so that's kind of at the crux of what we're working on. And if you think about it, there's actually a lot of examples of other geothermal plants that have already operated in this flexible type of mode. You look at the geysers, they're often required to curtail energy. In their case, when there's a lot of excess hydro, it turns out. There's also other examples like the Puna geothermal plant that curtails energy. Those two plants do it in different ways. At the geysers, they tend to shut in their production wells, whereas at Puna, they tend to just bypass the flow around the power plant. So again, that's curtailment. That's taking a load off the grid. Now, the thing about it is with geothermal as a near zero marginal cost energy source, if you are reducing your generation, foregoing revenue, that's not a recipe for success. And so we're starting to think about, well, how do we overcome that challenge? And it turns out with the type of system that we're developing at Fervo, which is really based on horizontal drilling, multi-stage stimulation treatments, and setting up connected systems of injection and producer wellbores in the subsurface that are connected very strongly in the subsurface hydraulically, but is surrounded by relatively low permeability rock. You think about it, and we started doing a lot of work on the feasibility of this again a couple of years ago. And the idea is at a simple level, we have a system where we have these injector and producer well pairs. We're flowing across the reservoir, generating, harvesting that heat and generating electricity. And at its base, it currently has like a base load rate of energy production. So in reservoir energy storage mode, what we would do is just curtail those production wells by simply closing the production wellheads while continuing to inject. And what that has the effect of doing is actually storing that excess fluid in the subsurface, in our case, in a series of well-connected fractures. And we actually can dilate those fractures against the earth stresses, store that pressure and energy in the reservoir. And you say we may do that during the day when solar power is there's a lot of excess solar on the grid. So we take that load off the grid during the day and then release that back, say 6, 7 p.m. When folks are getting home, and but solar's going down. And simply doing that by opening up the wellheads, releasing that excess stored pressure allows us to get a boosted flow rate above that base load energy level that we had initially. And so when we think about recovering that would have been produced energy, it looks a lot like a battery system that you can characterize just with things that people already understand, like round trip efficiencies. So we've been funded by the Department of Energy to take a closer look at this, first by the SBIR program to do a technical and commercial feasibility study. And more recently, we've been funded by ARPA-E Open to do field scale demonstrations. And we're working on this with a lot of great partners like Princeton University in the Zero Lab led by Professor Jesse Jenkins, who's looking at how this can impact the grid as a whole, and also some great technical partners like Berkeley Lab and Rice University here in Houston. So I'll just quickly say, what we found through some of those initial studies is that this approach, it actually does look from the grid's perspective exactly like a battery, and even in some cases approaching long duration energy storage style of generation profiles. We can get relatively high round trip efficiencies, 60%, 80% plus. It does depend on the reservoir properties. But when you look at it at a systems level, this can really increase the value of geothermal. And that's what this is all about. How do we make our power more valuable in a more challenging, increasingly challenging grid system? And we see that we can get about 50% increased value in the power and lower the total system cost of the grid by up to 15%. We just published that result in a peer-reviewed study. So hopefully that gives a lot more context. I know that was a lot of detail, but happy to dive in more also in the questions.
Yeah, no, I mean, that's great. I think I have another question that I want to pose to the whole panel, but before I do, I just want to kind of pivot to one of the themes that's coming up in some of the audience questions currently, and it's kind of the idea, Jack, to expand on, the baseload power is dead idea, or that nobody wants it anymore, to just kind of give some more color to, does it mean that that's no longer a play for geothermal, or is it just a matter of thinking differently, like you already mentioned, to increase value of geothermal, make it more flexible? Just to, since we're already on the topic, we just figured anyone can answer that as well. Just it's out there.
So I'd like to jump in here. One of the things that, as we are talking with utilities and talking with different partners, one of the biggest problems, curtailment factor. Oftentimes there is a priority to buy wind or solar, and therefore you are forcing base loads to curtail. And as Jack pointed out, the base load power, it's nuclear, whether it's geothermal, whether it's a coal-fired power plant, those are very expensive power plants to build. And it's a low margins game where you really need to have a high capacity factor in order to make your money. So if you are saying we want you to build a geothermal power plant, but we're only going to let you operate at 70% capacity factor over the course of the year, you're probably never going to build it because you're never going to make money. So I think that is the whole point there, that when he says, when we hear baseload is dead, it's basically dead in the water. Like, there is still that need, you still need baseload for the grid, but just because it's there doesn't mean you actually get to sell that power. So it's almost like a cat and mouse game right now. And that's why we're talking about battery storage.
Yeah, no, that's perfect. That's great. Anyone else want to add anything?
Yeah, I think it is funny. And, we're getting to a point where the value of geothermal is almost the highest it's ever been, because, all these different markets are and groups are calling for high levels of clean power. And of course, there's really nothing that can decarbonize at night. And yet they don't want geothermal right now in a lot of, or at least they think they don't. And I think, a lot of the work that the group of people here are working on is going to help change the mentality on that. But a lot of the sophisticated buyers already do recognize the value for this power. And you see, even in the last couple of years, so many new power purchase agreements being signed. And really that's for the same type of vanilla geothermal that's always been done. And I think there's still room for that. And that's important to recognize. But when we do go out and talk to customers, and I'll say whether it's utilities or even corporates, they are demanding this type of flexibility, and they really see that's where the long-term value is. And I'll say, one of the challenges is, there's a lot of people that are working on interesting technology on this, but of course, one of the challenges is more on the commercial side. And if you look at traditional geothermal power purchase agreements, virtually every single one of them that exists today is an energy only contract. And so you really don't get incentivized to produce power when it's the most valuable, whether it's for decarbonizing the most challenging hours of the day, at night, and or whether it's for providing reliability or elsewhere. And so I think changing structures, looking at creative structures like a shaped PPA, some folks are looking into that, could really help. So I think there's a big commercial innovation component to this as well. And I think the more conversations that like this one that are had, I think the more light bulbs will go off, and hopefully folks will start recognizing that.
Nick, I can, if you don't mind, I'd like to bring this discussion back to the purpose of our panel here. And that's energy storage, earth energy storage is what we talked about here. I think what Jack brought up is I find it kind of comical. Maybe that's not the right word, but that the statements that baseload is dead. But the reality is that they're using the earth as a storage battery, as has been explained here, represents a great opportunity for some of these baseload power generation operators, is that they can continue to operate or continue to generate thermal energy, store it, and then recover it during these periods when those renewables are at a minimum. We look at round trip efficiencies in the storage systems that we've looked at that exceed 80%. That's pretty good. There's a scramble in the market for large grid scale batteries, and people forget to look beneath their feet. That the earth represents a great opportunity and a ready-made battery to store energy, and that can be recovered. There is, just like a lithium battery, there is a charge time. It takes a while for your system to heat up. Once it heats, it then can operate at very high efficiency, and across a wide variety of applications, whether it's industrial heat, whether it's food production, whether it's power production. There are a whole range of, from very low temperatures to, when I mean very low temperatures, I mean geothermally speaking, to temperatures that exceed 200 degrees C. And people are literally scrambling about trying to find the battery that can help them get through the period of low production, when right beneath their feet is the battery that can help solve that problem. And folks in Europe are doing that. We're currently working on projects in Germany and projects in Switzerland, projects in Scotland, where they're doing the exact thing that we're talking about right here. And so our ability to leverage that, and DOE's vision to recognize the opportunity to work with organizations that are doing this and bring that technology to the States, and to work with organizations within the US to do this, I think is really this part of the message we need to get out there, that this work is being done, and that there is an opportunity there to help balance the grid, and the earth plays a critical role.
I think one point, I think Travis and Jake, both of you mentioned that round trip efficiency is very high. It's really after the initial charging, as Travis mentioned, that we are creating the synthetic reservoir, and the reservoir is not necessarily at high temperature. Actually, it's another feature of the SGR, that we don't need high temperature reservoir initially. We charge the hot fluid, preferably hot water initially, and we keep it there for a few months, or like 6 months or 3 months, to heat the rock. Once the rock is heated up, so it becomes the part of it's become like geothermal reservoir. Then when we keep the normal cycle, we start doing the normal cycle of injection and production, we almost get like 95% heat back, only like less than 5% loss. And also we get almost original temperature of the injected water. And that, I think that gives us more higher round trip efficiency. Of course, we lose some efficiency on the surface side with surface equipment like heat exchanger, turbine, and other equipment pipeline. But that's another feature, I think, for GB, that high round trip efficiency.
Yeah, no, that's all great. I mean, I think that was great color, and I think provides kind of, as Travis circled us back into what we're talking about here today, and it is the reason of, geothermal does not need to be looked at as just one thing. It's not just only a conversation about baseload power or et cetera. There's more to it, and then specifically it has a part to play in this future of the grid and in terms of storage and energy storage. And I think before we move to some of the audience questions, just want to I'll mix it in with an audience question. This can be for anyone who wants to take this. We kind of touched on it a little bit, whether it's corporate partnerships or PPAs, of today, and kind of as we move forward, how, first, what are we getting today in a PPA for geothermal in terms of a price per megawatt hour? And then moving forward, how do we work with utilities or corporates to develop PPAs and deal structures, as Jack was alluding to kind of honor geothermal's flexibility and potential to aid in this, peak demand? How do we really strive to work to get to a place where that's involved in the development of that deal?
Yeah, I can provide a little bit of context here. I mean, if you look historically, the value of geothermal PPAs has varied. You can look in the last boom cycle 10, 15 years ago, there were some pretty wild PPA prices, 80, 90, even above $100 a megawatt hour. I think if you look just over the last couple of years, geothermal is still, as I mentioned, there's been something like 15 new PPAs signed in the US just over the last 2 to 3 years, compared to maybe 10 that were signed from 2010 to 2018 or so. So there's really been a ramp up in geothermal and deals that are getting done, and you see those are coming in the 60 to 75 or so dollars a megawatt hour. Of course, when you think about that, comparing it to wind or solar in the 30s, 40s, or even with solar plus storage 30s, 40s, geothermal looks more expensive, but you can see that the utilities are choosing this because in a lot of these RFPs, they're getting deals. They're getting bids from solar and wind and solar plus storage, and they're choosing geothermal. So people are already seeing the value of that. I think the value of geothermal is going to continue to go up as it becomes more challenging to reach higher and higher levels of decarbonization. And there's, when we started Fervo 2017, there really weren't a whole lot of studies that supported this, but now there's been a ton released showing that, if you're trying to get above 50% hour by hour load matching and getting to a fully decarbonized system, it becomes exceedingly expensive, and geothermal all of a sudden becomes a very, very economic solution. And you look at groups like Google, who recently reached their 100% renewable energy targets on an accounting basis, and are now striving to take that next level to go 100% hour by hour load matching. And they look around and they see geothermal as one of the most attractive technologies out there to meet their demands. But there still is this contracting thing. To get back to your question, Nick, how do we incentivize it? If you look at again what's happening today, energy only PPAs, it becomes a challenge. And even I went out to a large geothermal operator, a geothermal field in California. Back in 2018, the same year that I heard that message from the CEC that baseload is dead. And I talked to the operator at this field, and they said, well, actually, we're still getting incentivized to produce power at noon on a summer day. And of course, that's when the value of power right now is the lowest in the Western markets. And so that was already baked into a long-term contract and had a perverse incentive there. But that gives me hope, because it does show that there is mechanisms in these contracts to value power at different hours of the day. And I think ultimately that's where we need to be heading, is in thinking through what are the hours of the day where the power is, where this type of clean power, reliable power is most valuable, and incentivize those hours.
If I might, I'd like to add to what Jack talked about here too. And there's a lot of complexities associated with these grid scale PPAs. It was just before the pandemic, I had a chance to visit a very large data center. and it was a cold winter day. And on one side of the data center, they had cooling towers that were bleeding megawatts of energy off to the atmosphere. And on the other side of the building, they had a 2-inch pipe bringing natural gas into the facility to heat the facility. And I was talking to the operator. I said, "Does this even make sense? That what you're doing here is you're on one side you're dumping energy into the atmosphere, on the other side you're buying energy to heat your system." Is that there's an opportunity here with the geothermal energy storage, earth storage, for individual organizations to reduce their power purchases or the amount of energy they consume out of the system by becoming more self-contained. So if you're a Google or a Meta or any other type of entity of such that has this excess heat, why not store it and then recover it? And on those cold winter days, recover that energy from the aquifer, bring it back to the system, and heat your system with it and reduce that amount of energy. And you don't have this paradox. On one side, you're dumping energy into the atmosphere. On the other side, you're buying energy and looking for the cheapest source of a carbon base or a renewable. In some of these high pressure days, you don't have the renewable option in these cold winter days. So I think there's opportunities here, not just at the grid scale, but I think there's opportunities within self-contained entities, whether you're a data center or a steel manufacturer, or whether you just operate a very large office building. And I think that's a novel new way of looking at the energy system.
Yeah, and I think no, that's all great, and want to try to move on and get some of these audience questions that are moving in for you guys. So a theme that's consistently coming up, kind of just summarize it into a two-part question. One is what's the value proposition here for a geothermal battery versus just a normal battery or other storage options like kinetic, or is this actually as efficient? And then the second part of that is what's the subsurface risk associated with these types of projects? Is it similar to that of an EGS or other type of geothermal project?
I'll jump in here real quick. I think the value proposition is pretty clear that when you're looking at lithium ion batteries as the primary storage, at least from an SGR perspective or geothermal, all of the studies show that it is going to be, and one of the published values optimized is approximately for the whole system about $125 per megawatt hour, and I think that was 5 years ago was published. So I think that is still going to be on the cost curve that can get better. But the other aspect here is that something we don't talk about, that we've been talking about, base load and always on power source. A geothermal battery is long-term duration storage. Those models were up to 1,000 hours for people. That is months of storage. So we're talking about seasonal storage now, not 4-hour battery. We're talking about weeks to months of power potential in the ground. That's the thing that we highlight the most. And then, as Travis pointed out, this can go from heating a single building all the way up to companies like Google, who are interested in full decarbonization hour by hour. So it's very flexible in terms of size as well.
I think for subsurface risk, I think there are few risks. One of them is like geochemistry. So we need to find out suitable reservoir with because we are injecting hot water, and hot water is reactive. It can react with the rock minerals, and it can deposit on the inside the pipeline, in the oil pipeline, in the surface equipment. So finding suitable reservoir without that geochemical problem is one risk. Second one is, I think, to stay away from fault and fractures. That's required for the SGR. Otherwise, your injected fluid will go somewhere else. It will not be stored for a seasonal purpose. And I think these two things are more important risk in the geothermal SGR.
Yeah, and I think that's a really good point. There are some considerations. You don't get anything for free. We have just published, it'll soon be available at INL, the Idaho National Laboratories website, the final report on our DOE funded project on reservoir thermal energy storage. You do have some complexities with geochemistry, but they can be managed. And it's so what you operate a thermal reservoir much like you would an oil and gas reservoir. It's not a inject and forget. You operate it using modern technologies and controls, and you can minimize the downsides of this. But one of the things that I wanted to bring up here was that we're talking about a system that can operate for many, many decades. And I think that's one of the great advantages over these chemical batteries that are so prevalent. There's a place for everything out there, but these reservoirs can operate for a generation or more if they're operated properly. And so you don't have to go in and replace the battery every 2 years or every 3 years or ever how many cycles that you're allowed to do it. And that is that these systems operated wisely can operate indefinitely. The Earth has demonstrated that these geothermal systems can persist for tens of thousands of years. And so that I think that's one of the great is the O&M costs, right? Once you get the wells drilled, you get the system in there and you get it operating, is that it'll operate forever, at least on a time scale of a building is concerned.
Yeah, thank you guys for that. That's great. I think that really gives perspective to the actual value here and the proposition of why you're saying this. And I mean, along with that, kind of we mentioned risks. One of the other questions that came in is how do we mitigate / live with the loss of the energy or the heat in these systems? Is there a component of that where is there energy loss during this storage time? So I'll open that up to anyone on the panel.
I think for my calculation, we have published few papers, and I think one report was published by INL as well. I think early 2012. So we showed that loss is very minimum. After few cycles, after charging, it's like 5% only loss. You get back 95% of the total heat. So we do not have that type of risk in the SGR.
Yeah. And we don't operate these systems. I mean, I know Jack talked a little bit about using pressure, but we're talking about using pressure here. I believe, I don't want to speak for Jack, but we're not operating at pressures that exceed the fracture pressure of the reservoir. So we're operating at pressures that are safe and benign in the system and recovering it. And so the big challenge is to set up your well field so that you can capture the most amount of energy. And as was stated previously, that charge time is relatively short. There is a charge time, but once you get the system operational, the amount of working and extract from the fluid increases and reaches an asymptote, and that number is very high. It's greater than 90% of the energy you put in, you can recover and utilize at the surface, recapture heat, put it back down, and make those cycles indefinitely.
Yeah, no, thank you for that. And another one here kind of just thrown in. This is kind of anyone can take it. Someone has a question about, is there an investment tax credit here regarding this style of development for geothermal?
I think it's a good question. The way that I envision it working, at least for our technology, which I think is a little bit different than some of what the other folks are talking about here, is at the end of the day, this is going to be geothermal production. It's going to look exactly the same. In fact, we want our technology and the product that we sell to look as familiar as it can to folks, because it can be really challenging to get these deals done. And so I envision selling geothermal PPAs, but again, where the value is captured in terms of where we're able to provide the most benefit in terms of reliability or decarbonization. And yeah, certainly, we would be taking advantage of the same type of tax credits that are available to geothermal.
Perfect. Yeah, thank you. And I kind of want to, I'll ask this question more as with a smile on my face that came in a few of the audience with basically creating a system like this with a geothermal, system plus the storage concept. Do we even need wind and solar anymore? Will it make wind and solar obsolete? I'll leave that, and then we can move to just a closing remark from each of you. But I smiled when I saw that, since we are here for the Pivot Conference.
Yeah. I'll answer that quickly. No, it doesn't make them obsolete. I think that go back to my earlier statement, which is the all of the above. It does make the penetration of wind and solar much higher because it deals with some of that base load problems that we have with transient production.
Yeah, I think the whole point there is renewable energy penetration. If we can increase that, meaning increasing the amount of wind and solar they can get on the grid through storing it in a geothermal battery or an SGR, I think that ultimately makes them more attractive, because now you have real storage, long-term storage that you can partner with it.
What I would say is I'd answer it in a little bit of a different way. I think this could most likely make long duration energy storage technologies obsolete, because if we can deliver reliable 24/7 clean power, but also in a flexible, dispatchable way that utilities really want it at a lower cost, which we've found in some of our studies that actually operating these on either daily cycles, getting up to 12 hours charging, 12 hours dispatching, or even longer durations, multi-day charging and discharging cycles, we can do that extremely cost competitively. And actually the study that we did with Princeton found that this is potentially one of the lowest cost long duration energy storage technologies out there. So I think folks don't quite have it on their radar yet. And I'll be, careful to say that we are still in the demonstration mode of phase of this technology, at least for Fervo. And we are, we've done some field scale testing over the last 2 years, and we'll continue to do so over the rest of this upcoming year. But if we can prove this out, it actually the additional cost to help make our systems flexible is extremely low relative to the geothermal system itself. So I do think that in the spirit of the geothermal conference here, the long duration energy storage folks should be worried.
Yeah, no, that's great. Well, I think we've had an incredible panel. Honestly, we could probably go for another couple hours, but I'm glad we got to touch on the subject and really just give people perspective on energy storage from the perspective of geothermal, and why Earth as a heat battery is an important topic, and one that really I think has a lot of value moving forward in the coming years to decades, and really helping us, grow geothermal's influence in the energy picture. I think it's, even as Travis mentioned, that there are use cases being done. Let's learn from them. Let's apply them. Let's really work on pushing this into the market and just continuing to push for geothermal, in the realization of the benefits that it has. It has so many things it can offer, and this is just one to kick off this amazing conference. And so it's been an honor to moderate with this, and got about a couple minutes for the panelists just to give a quick 30-second remarks for the end, but thank you all for listening in.
I think GB is the environment-friendly, long duration, and long lifespan energy storage system. That's it.
And I'll just add to what you said there. I think one of the big selling factors of this technology is that it means something to people across all the 50 states in the nation and across the globe. It just doesn't mean geothermal is applicable to places where there's high enthalpy systems. We can create the resource right where you live.
I'll just add, the Earth is an infinite battery, so we should use it as such. If the heat isn't beneath our feet, let's put it there and then use it later.
I'll just say I'm honored to be on the panel. Really appreciate it. Had a fun time discussing this exciting topic, and really looking forward to the week ahead. Thank you.
Yeah, thank you.
Thank you, guys.
You.
Thank you very much.